Okay, let us discuss this problem 1.253. So let me make the first figure and then we'll discuss the problem. So we have something of this kind of arrangement. It's slightly difficult to make, but we can try. So we have a cylinder kind of thing, and there is a rod, basically thread. This thread is attached, so these threads are bonded here. Some more threads are bonded here also, and this both are in the same plane, so there are some threads here. Now I think you are able to understand. So what will happen? So this can go down, so thread will unbond. So this is bonded thread, so this will go down and thread will basically unbond. So let us say figure 1.60. Now let me read the question. A uniform cylinder of mass m and radius r. So this is a uniform cylinder. Uniform cylinder. Mass is given to you and radius is also given to you. So mass is m and radius is r. It starts descending at a moment t is equals to due to gravity. So you see, due to gravity this will start going downward. So this will start at t is equals to 0. So t is equals to 0, motion starts. Neglecting the mass of thread. So you have to neglect the mass of thread. Find the tension in each thread and angular acceleration of the cylinder. So you have to find two things. What is the tension in each thread? Now one very important point. You see, these two threads are basically symmetrical. So this side distance and this side distance. So from this end of this cylinder, this distance, and from this end of the cylinder, this distance, both are equal. So I can say the system is symmetrical. So tension in this string, if T, then tension in this string also has to be T, because the system is symmetrical. There is no reason they will have different tension. System is symmetrical, and that's why we'll have both tension will be equal. So if I find one tension, my job is done. So symmetry says tension will be equal. So using symmetry, I can say tension is equal. Symmetry says tension is equal. Next thing you have to find what is the alpha. And part 3, what is the time dependence of instantaneous power developed by the gravitational force? So power developed by gravitational force, as a function of time. This can be also done. So let us say now this cylinder will go down. So let me make something like this. So I am making a free body diagram, something like this. If you look this cylinder from this side, what you will look? You will look this cylinder. So this cylinder I am making. You will see this thread. This thread is here, and the back thread is just in front of, so behind this thread. So this thread will not look. So if you are looking from this side, this thread will look, but this thread will not look. So I am basically making another thread just behind this thread. I am not able to see that thread. Let us say I am showing this by dotted, so that the back thread is basically shown by the dotted line. So now I can say tension in this thread is T, tension in this thread is T. So the total tension is 2T. And the downward force that is acting is mass into Z. Now let us say this is coming downward with acceleration A. Now see, this is moving also with acceleration alpha. I can find what is the relationship between alpha and A. So you see this point basically is in the rest, instantaneous rest. So this point of the thread has a 0 velocity. This thread is not opening, so this point of the thread has a 0 velocity. This means if I consider this point, this as a acceleration is downward, and due to the circular motion this will have alpha into r, upward acceleration. So this point, let us call this point as A. So point A will have two acceleration, because center of mass has acceleration A. So every point on this cylinder will have acceleration A downward direction. Now this is also rotating, so this will also have acceleration alpha r in the upward direction. Now you see, this length is fixed. So this A is fixed from the top, so it cannot, this thread cannot move. So the instantaneous point, this point that is basically touched with the cylinder is in the rest. So I can say acceleration of this point is 0 because this length has to be fixed. So I can say A is equals to alpha r. So I have one relationship, A is equals to alpha r. Now things are very simple. I can write equation for this. So if I write 2t mg minus 2t because doing downward, so let us say mg minus 2t is equals to mass into acceleration. This is equation 1. And another equation you will have torque of 2t. So 2t into r, this is torque, is equals to I alpha. Are you getting? Now let us assume this is a solid cylinder. So acceleration will be I will be mr square by 2. And alpha is nothing but A by r. We know alpha is A by r. So if you solve, so you will have 2t is equals to basically ma by 2. So this is equation number 1. This is equation number 2. So if you plug the value of 2t in equation number 1, you will have mg minus ma by 2 is equals to ma. Now if you solve for ma, you will have this m goes out, so you will have g is equals to a plus a by 2, that is a by 3. So a is basically, let me check. So if you have 1 plus, this is 3 by 2. So this is, if you add 1 plus a by 2, so this is 3a by 2. So you will have 3a by 2. Are you getting? So this will be a is equals to 2g by 3. So acceleration of this center of mass is given by 2g by 3. Now I know the alpha. Alpha is basically a times r. So in the question, first part, tension is found, you have to find the tension. So tension, now no, tension is ma by 4. If you use this equation, tension is ma by 4. And a is 2g by 3. So you will have m by 4 into 2g by 3. So what is the tension? You will have mg by 6. So this is the tension in one thread. Are you getting? Now this is the first part. Now the second part says you have to find, so we have found tension, we have to find alpha also. So alpha is a by r. So you can solve for alpha. Alpha is nothing but a by r. And now I know the a, that is 2g by 3. So alpha is a by r. So 2g by 3r. Now the next part, that is the third part question, says find out the power by the gravitational force as a function of time. Power is nothing but F dot B. Are you getting? Now you see, in this system center of mass, there is a force. We have to find the power due to gravitational force. So gravitational force is mg. Are you getting? So this gravitational force mg is acting in the downward direction. And the velocity of center of mass is also in the downward direction. So velocity of center of mass. So mg and v both are in the same direction. So F dot B is simply F into v. And F is mg into v. And v is, this is velocity of center of mass. Now we have to find velocity of center of mass. Initially this starts from rest. So v is equals to u plus at, acceleration a. Now we have found. So you see 2g by 3 is acceleration in the first part into t. So this is the velocity of center of mass. So the power generated will be F dot B. F is mg into 2g by 3 into t. So you will have, so 2 by 3, you can solve yourself, m g square t. So let us check this one. So this is the power generated by the gravitational force. Are you getting? In this question, what is the important point? In this question, important point is you have to assume the tension, these two tension must be equal. This is because system is symmetrical. Another important point you have, in this case, this is a case of pure rolling, that is alpha is equals to AR. Because the point that is in the touch, so the string that is in the touch with the wheel, it should have zero velocity. Because if you consider, so let me explain again, that is important point here. If you consider a point here A, if you consider a point that is on the thread, and if you consider a point that is on the disk or in the cylinder, if you consider a point on the thread, it should have a zero velocity because thread is not changing its length, it remains constant. But this side you have this point, it also has to be zero velocity because this point I can consider either on the thread or I can consider on the cylinder. So this means acceleration of this point has to be zero. Are you getting? One can also argue the same statement, that is alpha is equals to AR, using another statement, something like this. You can see this thread is basically not slipping over this cylinder. So thread is not slipping over this cylinder. This means the velocity of thread should be equals to the velocity of this point, that the in contact point. But the velocity of this point is zero because this thread is not getting slackened. If there is a velocity the top side, it will have, this thread will become slackened. If this has a velocity lower side, then this will break. So neither this thread becomes slackened or neither it becomes breaking. So this means this has to be zero velocity. This contains zero velocity, corresponding it has to has zero acceleration. So that is the acceleration in this direction should be equals to acceleration in this direction. If it has acceleration in the upward direction or downward direction, it will gain a velocity, and if it gains a velocity, it will break. If it gains a velocity in the downward direction, it will break. If it gains a velocity in the upward direction, this will slacken. So this thread always remains taut. In that case, I can say acceleration of this point has to be zero. Otherwise, it will gain a velocity, and once it gains a velocity, this thread either becomes slackened or it becomes broken. So I can say the velocity of this point is zero, relative acceleration of this point is also zero, so E is equals to alpha of R. We have to say this case. Now let us discuss the next problem.